three words. Tree, that is 3. Go, that is sides. And metry means measurement. This is a Greek word used trigonometry. Now, trigonometry is the study of relationships between sides and angles of a right angled triangle. So, here in this chapter we will be always talking about a right triangle. Now, suppose I am given one right triangle. Now let this be a right triangle ABC. So I am giving it the name ABC. And the angle which I am watching is angle A. So here already we know that angle B is 90 degrees. So opposite to angle B will be my hypotenuse, which we denote with H. Now the angle which is given to me, that is angle A, the side opposite to angle A will be either you can say perpendicular or opposite. So I will write perpendicular or opposite side because it is opposite to the angle. And the side which is with the angle, see this BA side is touching angle A. So BA will be my adjacent side, and adjacent side we call as base also. So adjacent side I will be using the word B for that, and perpendicular I will be using P. Now this is one case, but it can be in the other way also. Okay, suppose why always angle A is the angle to be seen? It can be like this, A, B, C. Now the person watching is at angle C. So then opposite side will be opposite to that angle. So this will be my perpendicular side, this will be my adjacent, and this will be my hypotenuse. Now with this, to remember the formulas here of sin theta, tan theta, there is a simple trick. You have to remember Pandit Badri Prasad हर बोल सोना चांदी तोल. Now see, there is a simple technique. First, from Sona I will be taking S. So S means sin theta. So that will be the first letters P by H. Then cos theta B by H. And tan theta, see T from tol, and tan theta will be P by B. Now, three more relations are there, that is cosec. Cosec means opposite of sine. So opposite means the values will just change. Denominator will go into numerator and numerator into denominator. Then cos opposite is sec. So H by B. And the third one is cot, opposite of tan. So B by. If you know this much, the first exercise easily you can solve. Now, here in question 1, he has given triangle ABC right angled at B. AB is given to me as 24 centimeter, BC is given to me as 7 centimeter. Then he has asked me to determine sin A, cos A, sin C and cos C. So, to do this, see, now we know that this is a right angle triangle, so it will follow the Pythagoras theorem. The Pythagoras theorem says that AC square equal to AB square plus BC square. So AC I don't know, so to find AC I will use this formula, Pythagoras theorem. So AC square will be equal to 24 square plus 7 square. Now 24 square is 576 plus 49. So this is 625, which is 25 square. So therefore AC equal to 25. Now I know all the three sides. Now he has asked me to find sin A. So see, if I take sin A according to the formula, that is Pandit Badri Prasad Har Har Bole, Sona Chandi Tole. So according to that, if I say angle A, if I take, opposite will be this and adjacent will be this. So now I have to just put the values. So P by H. So P means perpendicular, so that is 7, and H means hypotenuse, that is 25. And cos A, base by hypotenuse, so that is 24 by 25. Now in the B case, the angle given to me is sine. So sine angle C, if I take as the angle, the opposite side will be of angle C will be 24. So 24 by 25, and cos C will be B by H. So adjacent side, there it is 7 by 25 hypotenuse. In next question it is given, in the given figure, find tan P minus cot R. So again, see, I am given PQ and QR. One angle is P, one angle is R. But see, here the problem is I don't know the base QR. So to find the base, I again have to use the Pythagoras theorem. So I can say PR square equal to PQ square plus QR square. So PR is 13 square equal to 12 square plus QR square. So QR square will be 13 square. So 69 minus 144, 12 square. So that is 25. So QR will be 5 centimeter. So now I am writing 5 centimeter here. Now tan means, what was that? Pandit Badri Prasad Har Har Bole. So tan will be, tan P would be P by B, and cot R. Cot means opposite of tan. So B by P. So here tan P will be equal to P. So see, I am taking P angle to tan, so perpendicular, so that is 5 and base is 12. And here cot R. Now I am taking R, this one, see this angle. Now perpendicular will be 12 and base will be 5. So 5 by 12. Now they have asked me to find tan P minus cot R. So putting the values, I will get 5 by 12 minus 5 by 12. So that will be 0. Now next question is sin A equal to 3 by 4. Find cos A and tan A. So I have drawn the figure. Sine means opposite or perpendicular upon hypotenuse. So perpendicular will be 3, hypotenuse will be 4. So base I need to find. So can I say AC square equal to AB square plus BC square? So 4 square equal to AB I don't know. So AB square plus BC square will be 3 square. So AB square will be 16 minus 9. So 7. So AB I can say root 7. Now AB is root 7. So cos A will be base by hypotenuse and the other one is 10A, that is perpendicular upon base. So cos A will be base. Base is root 7 by 4 and perpendicular 3 by root 7. Now next one, it is given if 15 cot A equal to 8, find sin A and sec A. So cot means base upon hypotenuse. So similarly I have noted it down here in the figure. Now can I say AC square equal to AB square plus BC square? So 8 square plus 15 square. So 8 square will be 64 and 15 square will be 225. So that is 289 square or 289. So that will be 17 square. So AC equal to 17. Now after noting down this, see here cot A, here it 15 is in multiply. So on the other side it will come in division. So that way I got this 15 and 8. Now he has asked me sin A. So this is the angle which I have to see. So sin A equal to P by H. So perpendicular is 15 and hypotenuse is 17. Now the second one which he has asked is sec A. So sec means opposite of cos. So H by B. So H is 17, B is 8. Now next I am given sec theta equal to 13 by 12. Calculate all other trigonometric ratios. Now sec means hypotenuse upon base. So first I have denoted that two values and angle A I have taken as theta degree. And then I have find by using Pythagoras theorem BC, and now I will be finding all the relations. So sin theta will be opposite upon perpendicular upon hypotenuse, so that will be 5 by 13. Cos theta will be base by hypotenuse, so that will be 12 by 13. Tan theta P by B, so 5 by 12. Cosec theta H by P, so 13 by 5. And cot theta, already sec is given, so sec I am not finding, so by P, so that will be 12 by 5. So I got all the remaining trigonometric ratios. Now in the next question he has given me angle A and angle B are acute angles such that cos A equal to cos B. Then prove that angle A equal to angle B. So here first of all let us assume a triangle ABC. Let triangle ABC be a triangle such that CD is perpendicular to AB. Now cos A equal to cos B, it is given. So cos A if I see, cos A will be AD upon AC equal to cos be BD upon BC. So if these are equal, so now can I say AD upon BD equal to AC upon BC? So let us suppose this as K. Now I can say AD equal to K BD 1, AC equal to K BC 2. Now using Pythagoras theorem in triangle CAD and triangle CBD, so we get CD square equal to BC square minus BD square, that is 3 number, and CD square equal to AC square minus AD square, that is 4 number. So if you see carefully, 3 and 4 LHS are equal, so I can say RHS also will be equal. So now as we have got in 1 and 2 the values, I will be substituting that values here. So here I am keeping BC square minus BD square, and here AC is KBC, so whole square minus KBD whole square. So if I take K square common, so I will get BC square minus BD square. Now both sides, see, both sides BC square and BD square are equal. So if I cut the bracket, I can say K square equal to 1. So therefore AC equal to BC. So if AC equal to BC, then angle A equal to angle B, because opposite angles of equal sides are equal. Now here the question says if cot theta equal to 7 by 8, find the value of 1 plus sin theta into 1 minus sin theta upon 1 plus cos theta into 1 minus cos theta, and second one they have asked us is cot square theta. So for first of all I have found the third side using Pythagoras theorem. Now he has asked me 1 plus sin theta and 1 minus sin theta. So can I say this will be nothing but a plus b, a minus b, so this will be 1 minus sin square theta upon 1 minus cos square theta. Now if I find sin theta and cos theta, so sin theta will be 8 upon root 113. So sin square theta will be 64 by 113 because squaring both the sides, and cos theta equal to 7 by root 113. So cos square theta will be 49 upon 113. So now I have to put the values in 1 minus sin square theta upon 1 minus cos square theta. So putting the values 1 minus 64 by 113 upon 1 minus cos square. Cos square is 49 by 113. So I will get 113 minus 64 by 113. 113 minus 49 upon 113. So this I will get as 49 by 64 because both the denominators will get cancelled. Now the first one says this one. Now second one, it says cot square theta. So cot means base upon perpendicular. So base is 7 and perpendicular is 8. So this is 49 by 64. So see, in both the answers I got the same, so I can say both are equal. Now here I am given 3 cot A equal to 4. Then check whether 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A or not. So here cot A will be 4 by 3. So putting the values, I got AC equal to 5. So now I have to find tan A. So tan A will be perpendicular upon base. So that will be 3 by 4. So I can say tan square A will be 9 by 16. Sin A will be perpendicular upon hypotenuse. So 3 by 5. So sin square A will be 9 by 25 and cos A equal to 4 by 5. So cos square A will be 16 by 25. Now putting the values in LHS, I will get 1 minus tan square A upon 1 plus tan square A. So this will be 1 minus 9 upon 16 whole upon 1 plus 9 upon 16. So 16 minus 9 upon 16, 16 plus 9 upon 16. So 16 minus 9, 7 upon 25. So I got LHS 7 upon 25. Now solving RHS, cos square A minus sin square A. So 16 upon 25 minus 9 upon 25. So that will be 7 by 25. Therefore I can say 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A. Now next I am given tan A equal to 1 by root 3. Find sin A cos C plus cos A sin C and cos C minus sin A sin C. So here I am given tan A equal to 1 by root 3. So putting the values in the triangle, I got AC equal to 2. Now so I can say sin A will be opposite. So opposite is 1 by hypotenuse 2. Cos A root 3 by 2. Then I have to find sin C and cos C. So sin C will be root 3 by 2 and cos C 1 by 2. Now for the first one I will be putting all the values sin A cos C plus cos A sin C. So putting the value, sin A is 1 by 2, cos C is 1 by 2 plus cos A root 3 by 2 into root 3 by 2 sin C. So this is nothing but 1 by 4 plus 3 by 4. So 4 by 4, that is 1. Now second one it says cos A cos C minus sin A sin C. So again putting the value, cos A is root 3 by 2, cos C is 1 by 2, minus sin A is 1 by 2, sin C is root 3 by 2. So this is also root 3 by 4 minus root 3 by 4. So that is 0. Now next one, it is in triangle PQR, right angle at Q, PR plus QR equal to 25 centimeter and PQ equal to 5 centimeter. Determine the value of sin P, cos P and tan P. So I am given PR plus QR equal to 25. Only two sides I am given. One is sum of two sides and one is only one side. So let QR be X centimeter. So PR will be 25 minus QR. So that is 25 minus X. Now, using Pythagoras theorem, PR square equal to PQ square plus QR square. In place of PR, I will put 25 minus X whole square equal to 5 square. So X square. So 25 square will be 625 minus 50x plus x square equal to 25 plus x square. So both side x square got cancelled. Now can I say 625 minus 25 equal to 50x? So x equal to 600 upon 50. So x is 12 centimeter. So if x is 12 centimeter, therefore QR equal to 12 centimeter. So PR will be 25 minus 12, that is 13 centimeter. So now this is 12 centimeter, this is 13 centimeter. Okay. So sine P will be sine P. So opposite. So opposite is QR upon PR. So 12 by 13. Cos P is cos P. So PQ upon PR, so that is 5 by 13, and tan P, that will be QR upon PQ, 12 by 5. The 11th question is, state whether the following are true or false. Justify your answer. The value of tan A is always less than 1. So this will be false, because in triangle M and C, angle N equal to 90 degree, MN equal to 3 centimeter, NC equal to 4 centimeter, and MC equal to 5 centimeter. Tan M will be 4 by 3, which is greater than 1. Hence, I proved that it can be greater than 1. Then second one is sec A equal to 12 by 5 for some value of angle A. So this will be true. Again, I am saying let triangle M and C be there with angle N equal to 90, MC equal to 12, MB equal to 5. So MC square equal to MN square plus NC square. So 12 square equal to 5 square plus NC square. So NC square will be 144 minus 25. So 119 K square. So such triangle is possible as it follows the Pythagoras rule. Then third one, it says cos A is the abbreviation used for the cosecant of angle A. This is also true as it is the short form of cosecant. Then fourth, it says cot A is the product of cot and A. This is false, as cot A is not the product of cot and A, but it is cot of angle A. Then fifth one, it says sine theta equal to 4 by 3 for some angle theta. This is also false. See, sine theta will be opposite upon hypotenuse, and hypotenuse is the longest side of the triangle. So, therefore, sine theta can't be greater than 1. Now, today we are going to learn a technique to remember all the formulas of sine theta, cos theta and tan theta. See, now if I take my left hand, my thumb will be my 0 degree, then 30, 45, 60, 90. I should label them like that. Now, for sine theta, the formula says square root of fingers below upon 2. Now, suppose if you say sine 90 I want to find. So, in such case, what I will do, I will first see check 90, where it is. So, at the top. Below that, how many fingers are there? 4. So, I will write root 4 by 2. Now, root 4 is 2, 2 by 2 is 1. Then, if you say sine 30, so sine 30, how many fingers are below that 30 degree? Only one thumb is there. So I will write root 1 upon 2. So root 1 is 1 by 2. Then same way, sine 60. Sine 60, how many are there below that? 3. So root 3 by 2. Now sine 45. Sine 45, it will be 2 fingers. So root 2 by 2. Only here I need to do a simple calculation. Root 2 I will write as root 2. 2 I will write as root 2 into root 2. So that will be 1 by root 2. Now, to find sine 0, how many fingers are below 0 angle? None. So 0 by 2, that is root 0 by 2. So 0 upon 2. So that will be 0. So from this I got the whole table of sine theta. Sine 0, sine 30, sine 45, sine 60, sine 90. Now for cos theta, the formula says fingers above square root upon 2. So I have to just do the square root of the fingers above that angle. So suppose if I want to find cos 0, the cos 0 will be how many fingers are above that? 4. So root 4 upon 2. So that will be 2 by 2. So 1. Now if I find cos 30, 3 are there above that. So root 3 by 2. Then cos 60, 1 is there only. So root 1 by 2. So 1 by 2. Cos 90. So there is no finger above that. So I will write 0 upon 2. So that is 0. Now coming to cos 45. Here also, see, 2 fingers are above. So root 2 by 2. So again I will get 1 by root 2 here also. Same way, if I go for tan theta, the formula says square root of fingers below upon square root of fingers above. So 10 0. So fingers below, so 0 upon fingers above, so above are 4, so 0 by 2, that is 0. Now 1045, so for 1045 the formula says fingers below, so below fingers are 2, so square root of 2 upon fingers above, so that are also 2, so that will be 1. Then 1060, fingers below are 3, so root 3 upon fingers above 1, so root 3. And 1090, fingers below are 4, so root 4 upon fingers above 0. So this comes as 2 by 0, so that is not defined because anything upon 0 is not defined. If I reverse sine, I will get cosec. If I reverse cos, I will get sec. And if I reverse tan, I will get cot. So this is an easy way to remember the whole table. Now moving to exercise 8.2, question 1. First one says, evaluate the following: sine 60 degree, cos 30 degree, plus sine 30 degree, cos 60 degree. So here we will be using the sine theta, cos theta and tan theta table. So we know that sine 30 degree will be equal to half, sine 60 degree equal to root 3 by 2, cos 30 degree equal to root 3 by 2, and cos 60 degree equal to 1 by 2. Now putting values, sine 60 means root 3 by 2, cos 30 is root 3 by 2, plus sine 30 is 1 by 2 into 1 by 2. So this became 3 by 4 plus 1 by 4. So that is 1. Now in that the second one says 2 tan square 45 plus cos square 30 minus sine square 60 degree. So we know that sine theta, sine 60 degree will be equal to root 3 by 2, cos 30 degree is root 3 by 2, and tan 45 is 1. So putting values, 2 into 1 square plus sine 30 is root 3 by 2, so root 3 by 2 whole square minus root 3 by 2 whole square. So this both get cancelled, so answer is 2. Now third one says cos 45 upon sec 30 plus cosec 30. So putting the values, I will get 1 by root 2, as cos 45 is 1 by root 2. Now sec 30, so 2 by root 3 plus 2. So this will be 1 by root 2 whole upon 2 plus 2 root 3 by root 3. I have just done the LCM. Now denominator will go in numerator, so root 3 upon root 2 into 2 plus 2 root 3. So that will be root 3 upon 2 root 2 plus 2 root 6. Change of the sign, so I will get 2 root 2 minus 2 root 6 upon 2 root 2 minus 2 root 6. So this I will get as root 3 into 2 root 2 minus 2 root 6 upon 2 root 2 whole square minus 2 root 2 whole 2 root 6 whole square, a square minus b square. So this will be 2 root 6 minus 2 root 18 upon 4 into 2 minus 4 into 6. So if I solve it, so 2 root 6 minus 18 is 9 will come out, so it will become 3. So 3 2s are 6. So 6 root 2 and this will be minus 16. So I can say minus 2 root 6 plus 6 root 2 upon 16. I have multiplied the minus sign in the numerator. So now if I take 2 common and cut, so this will become 3 root 2 minus root 6 by 8. Now fourth one says sin 30 plus tan 45 minus cosec 60 upon sec 30 plus cos 60 plus cot 45. So putting the values 1 by 2 plus 1 minus 2 by root 3 upon 2 by root 3 plus 1 by 2 plus 1. So doing the LCM 2 root 3. So root 3 plus 2 root 3 minus 4 whole upon, again the LCM will be 2 root 3. So 4 plus root 3 plus 2 root 3. So this will come to as 3 root 3 minus 4 upon 4 plus 3 root. Rationalizing the denominator, so I will get 3 root 3 into 4 minus 3 root 3 minus 4 into 4 minus 3 root 3 upon 4 whole square minus 3 root 3 whole square. So this will come to 12 root 3 minus 27 minus 16 plus 12 root 3 upon minus 11. So 12 root 3 and 12 root 3 will be 24 root 3 minus 43 upon minus 11. So if I take minus sign up, so this will become 43 minus 24 root 3 by 11. Then fifth one in that says 5 cos square 60 plus 4 sec square 30 minus tan square 45 degree upon whole upon sin square 30 plus cos square 30. So this will be nothing but 5 into 1 by 2 whole square plus 4 into 2 by root 3 whole square minus 1 upon 1 by 2 whole square plus root 3 by 2 whole square. So that will be 5 upon 4 plus 4 into 4 by 3 minus 1 whole upon 1 by 4 plus 3 by 4. So this will form to 5 by 4 plus 16 by 3 minus 1 upon LCM will be 4, so 1 plus 3. So now in the numerator if I do LCM, so it will be 12. So 15 plus 64 minus 12 whole upon 1. So this will come to 67 by 12. Now next question is choose the correct option and justify your choice. So it is an MCQ. 2 tan 30 upon 1 plus tan square 30 degree equal to whether it is sine 60, cos 60, tan 60 or sine 30. So the simplest thing is I put the values and I solve it first. So 2 tan 30. So 2 into 1 by root 3 whole upon 1 plus 1 by root 3 whole square. So this will be 2 by root 3 whole upon 1 plus 1 by 3. So 2 by root 3 whole upon 3 plus 1 by 3. So that will be 2 by root 3 into 3 by 4. So 3 by 2 root 3. So if I write 3 as root 3 into root 3 upon 2 into root 3, so 1 root 3 get cancelled. So this is coming to root 3 by 2. So which is equal to sine 60 degree. 1 minus tan square 45 degree upon 1 plus tan square 45 degree. So here the options given to me are A 1090, B is 1, C is sine 45 and D1 is 0. So solving, if I put the values, so tan square 45 means 1 square upon 1 plus 1 square. So this will be 1 minus 1 upon 2. So 0. So option D is the correct one. Now coming to the third one, it says sine 2A equal to 2 sine A is true when A equal to, first option is 0 degree, second option is 30 degree, third option is 45 degree and fourth option is 60 degree. Now here I am solving first LHS, that is sine 2A for degree 0. So sine 0, so 2 into 0 degree, so that will be 0. RHS 2 sine A, so that will be 2 into sine 0 degree, so that will also be 0. Now fourth one says 2 tan 30 upon 1 minus tan square 30 degree, and options given are cos 60, sin 60, tan 60 or sin 30. So if I solve this one, see 2 tan 30 upon 1 minus tan square 30. If I start putting the values, so this will be 2 into 1 by root 3 whole upon 1 minus 1 by root 3 whole square. So this will be 2 by root 3 upon, so this will be 2 by root 3 into 3 by 2. So I will get root 3, that is tan 60. Now next question is tan a plus b equal to root 3 and tan a minus b equal to 1 by root 3, where 0 degree is less than a plus b and less than or equal to 90 degree and a is greater than b. So find a and b. So tan a plus b equal to root 3. We know that root 3, so I can say tan 60 equal to tan a plus b. So therefore a plus b equal to 60 degree. So let me put this as first number, and then tan a minus b equal to, I am given 1 by root 3. So tan 30 degree equal to tan a minus b. So I can say a minus b equal to 30 degree. Let it be 2. Now solving 1 and 2, a plus b equal to 60, a minus b equal to 30. So if I add them, so 2a equal to 90. So a I will get as 45. Putting a equal to 45 in 1, a plus b equal to 60 degrees the equation, so it implies 45 plus b equal to 60. So therefore b will be 15 degree. Now question 4 is, state whether the following statements are true or false. Justify your answer. Sin a plus b equal to sin a plus sin b. So to justify, let a equal to 60 degree, b equal to 30 degree. So sin a plus b will be equal to sin 60 plus 30. So that will be sin 90, that is 1. So first I have solved LHS. Now let me solve RHS. So RHS says sin A plus sin B. So sin 60 plus sin 30. So sin 60 is root 3 by 2 plus sin 30 is 1 by 2. So taking the LCM, I will get root 3 plus 1 by 2. So therefore LHS is not equal to RHS. Then second one says the value of sin theta increases as theta increases. So here we know that sin 0 degree is 0, sin 30 degree is 1 by 2, sin 45 degree equal to 1 by root 2, sin 60 degree equal to root 3 by 2, and sin 90 degree equal to 1. So therefore values of sin theta increases as theta increases. So it is a true statement given to me. The third one says the values of cos theta increases as theta increases. So if we put the values, so cos 0 degree equal to 1, cos 30 degree equal to root 3 by 2, then cos 45 degree equal to 1 by root 2, cos 60 degree equal to 1 by 2 and cos 90 degree equal to 0. So it is false, as the values are decreasing, not increasing. Then fourth one says sin theta equal to cos theta for all values of theta. So here if I take simple sin 30 and cos 30, so sin 30 equal to 1 by 2, cos 30 is root 3 by 2. So therefore sin 30 is not equal to cos 30. So this statement is false. Then fifth one says cot A is not defined for A equal to 0 degree. So cot 0 degree is equal to cos 0 upon sin 0. So that is 1 upon 0, which is not defined. So this is. Now I am joining the diagonals and in the center I am writing 1. Now here I am writing sin, cos, cot, cosec, sec and tan. Now if you see carefully, here sin theta, again sin theta, I am having cosec theta. So I can say cosec theta equal to 1 upon sin theta. Same way sec and cos are against each other, so I can say sec theta equal to 1 upon cos theta. Same way cot theta equal to 1 upon tan theta. So conversion is easy here. Now if you move clockwise from tan theta, if I move clockwise, I can say tan theta will be equal to sin theta upon cos theta. Now if I want to find sin theta, so sin theta will be cos theta upon cot theta. Now how I can get this? See, cos theta upon cot means cos upon sin. So if I reverse the denominator, I will get sin theta upon cos theta. So cos theta cancel, so I will get sin theta. Same way, if I want to find cos theta, I can say cot theta upon cosec theta. So if clockwise I go, I will get one patterns of formula. Then cot theta will be cosec theta upon sec theta. Many times these types of sums are asked, that's why I am showing you that. Then next is sec theta, that is tan theta upon sin theta. Now one question arises in my mind, if instead of clockwise, if I go anti-clockwise, then see, if I start with here cot theta, so I can say cot theta will be equal to cos theta upon sin theta. So both the ways I can generate the formula. Now even the three main formulas, that is sin square plus cos square equal to 1, that one I can get here in this triangle without remembering that. Now see how I can get If you see the first triangle of the hexagon, let me draw the hexagon again to show. See, this is my hexagon with diagonals. And here it was written 1. This is my 1 in the center. And here it was sine, cos. So, if I take this one triangle, so I can say sine square theta. See, this one point plus this point. So, cos square theta equal to, here in the center at the third vertex I have written 1. So, this will be 1. Same way, if I take this triangle, here it was tan theta and here it was sec theta. So, I can say tan square theta plus 1 equal to sec square theta. Same way, here it was written cosec and cot. So if I take this triangle, I can say 1 plus cot square theta equal to cosec square. So all the formulas I can remember using this technique. Exercise 8.3, first question says, express the trigonometric ratio sin A, sec A and tan A in terms of cot A. So first is sin A. So I can write sin A equal to square root of sine square, because square root square will be equal to 1 power. Now this I can write as square root of 1 upon cos sec square A, because sin A equal to 1 upon cosec A. Now cosec A, can I write 1 upon 1 plus cot square A, because 1 plus cot square A equal to cosec square A. Identity. So I can say the final answer will be 1 upon root of 1 plus cot square A. Then second one is sec A. Now second one says sec A. So sec A we can write as sec square A equal to 1 plus tan square A. This is the identity. Now in this identity I am changing 1 plus tan square I am writing as 1 upon cot square A. So if I make LCM, I will get cot square A plus 1 upon cot square A. So I don't want to find of sec square A, I want sec A. So sec A will be square root of cot square A plus 1 upon cot square A. So if cot square A I take out of the bracket, I will get cot square A plus 1 upon cot. Third one is tan A. So tan A I want to convert it in cot A. So can we say tan A equal to 1 upon. Now second question says write all the other trigonometric ratios of angle A in terms of sec A. So first of all I can say sine square A plus cos square A equal to 1. So therefore sine square A will be equal to 1 minus cos square A. So if I want to write cos in sec, I can write 1 upon sec A square. So if I do LCM, see here I have used cos A equal to 1 upon sec A formula. Now if I do LCM, I can say sec square A minus 1. So I got the first one, but see, still it is in sine square and they have asked me sine A. So sine A will be root of sec square A minus 1 upon root of sec square A. So if I take out root, so it will be sec A. Now same way cos A I will get directly. Cos A will be 1 upon sec A. Now tan A means sin A upon cos A. So just now above we have got of sin A, that was square root of sec square A minus 1 upon sec A whole upon 1 by sec A. The above two values I have used. So this I will get as root of sec square A minus 1 upon sec A into sec A upon 1. So sec A cancel. So I will get root of sec square A minus 1. Now cosec A equal to 1 upon sin A. So same again sin A value I will be putting. So that will be 1 upon root of sec square A minus 1 upon sec A. So I will get sec A upon root of sec square A minus 1. Then the last one is cot A equal to 1 by tan A. So already tan A we have got 1 upon root of sec square A. Now question 3 says choose the correct alternative, justify your answer. So 9 sec square A minus 9 tan square A is given. So can I say 9 if I take common sec square A minus tan square A? So this is nothing but at an identity, so I can say 9 into 1 because sec square A minus tan square A equal to 1. So this. Now second one says 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. So first I am converting everything into sine and cos. So 1 plus tan theta will be sine theta upon cos theta. Sec theta will be 1 upon cos theta. Now cot theta will be cos theta upon sine theta minus cosec will be 1 upon sine theta. Now I am doing LCM in both the brackets. So in the first bracket I get cos theta plus sine theta plus 1 upon cos theta. In the second bracket I will get sine theta plus cos theta minus 1 upon sine theta. Now I am taking cos theta plus sine theta as A and 1 as B. So it will be A plus B and A minus B. So A square minus B square upon A into B. So I got this will be cos square theta plus sine square theta plus 2 sine theta cos theta minus 1 upon sine theta cos theta. So we know that cos square theta plus sine square theta equal to 1. So 1 plus 2 sine theta cos theta minus 1 upon sine theta cos theta. So now 1 and minus 1 got cancelled. So it came as 2 sine theta cos theta upon sine theta. Now third one says sec a plus tan a into 1 minus sine a, and 4 options are given. So first I am converting everything into sine and cos. So sec a will be 1 upon cos a plus tan a will be sine a upon cos a into I will have 1 minus sine a. So now doing LCM I will get 1 plus sine a upon cos a into 1 minus sine a. So 1 plus sine a into 1 minus sine a will be 1 minus sine square a upon cos a. So 1 minus sine square a will be cos square a upon cos a. Now so fourth one says 1 plus tan square a upon 1 plus cot square a equal to. So here 1 plus tan square a will be sec square a and 1 plus cot square a will be cosec square a. If I convert them into sine and cos, I will get 1 upon cos square a whole upon 1 upon sine square a. So this will be 1 upon cos square a into sine square a upon 1. Now the next one says prove the following: cosec theta minus cot theta whole square equal to 1 minus cos theta upon 1 plus cos theta. So first I am taking LHS and I will bring it to RHS. So cosec theta minus cot theta whole square. Now converting everything to sine theta and cos theta. So I will get 1 upon sine theta because cosec theta means 1 upon sine theta and cot theta means cos theta upon sine theta and whole square. So this came to 1 minus cos theta upon sine theta whole square. So if I open the square, I will get 1 minus cos theta whole square upon sine square theta. So if I write 1 minus cos theta whole square as 1 minus cos theta into 1 minus cos theta. Sine square theta I can write as 1 minus cos square theta. So this will be 1 minus cos theta into 1 minus cos theta. Now the lower one is 1 minus cos square theta. So I can say 1 minus cos theta into 1 plus cos theta. So one bracket gone, so it came to RHS. See here. Now here the second one says cos a upon 1 plus sine a plus 1 plus sine a upon cos a. So again I am taking LHS. Cos a upon 1 plus sine a plus 1 plus sine a upon cos a. Now I am taking LCM. So LCM will be 1 plus sine a into cos a. So this will become cos square a plus 1 plus sine a whole square. So opening the bracket I will get cos square a plus 1 plus 2 sine a plus sine square a upon cos a into 1 plus sine a. Now cos square a plus sine square a will be 1 and 1 plus 1 will be 2. So 2 plus 2 sine a upon cos a into 1 plus sine a. So if I take 2 common, 1 plus sine a upon cos a into 1 plus sine a. So 1 plus sine a will be cancelled. So I got 2 upon cos A. Now 2 upon cos A is nothing but 2 upon 2 sec A, because cos 1. Now third one is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus sec theta into cosec theta. So first here also LHS I am taking and I am converting it into sin theta and cos theta. So tan theta will be sin theta upon cos theta whole upon cot theta 1 minus cot theta. So 1 minus cos theta upon sin theta plus cot theta, so cos theta upon sin theta whole upon 1 minus sin theta upon cos theta. So now doing the LCM in the denominator, I will get sin theta upon cos theta whole upon sin theta minus cos theta upon sin theta plus cos theta upon sin theta whole upon cos theta minus sin theta upon cos theta. So this becomes sin theta upon cos theta into sin theta upon sin theta minus cos theta plus cos theta upon sin theta into cos theta upon cos theta minus sin theta. Now here sin theta into sin theta is sin square theta upon cos theta into sin theta minus cos theta. Now here it is cos theta minus sin theta. To make it sin theta minus cos theta, I have to take minus sign out. So that minus sign I am bringing in the middle. So cos square theta upon sin theta into sin theta minus cos theta. So now making the LCM, I am making the LCM sin theta cos theta into sin theta minus cos theta. So this becomes as sin cube theta minus cos cube theta. So this will come as sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta, and whole upon I am having sin theta cos theta into sin theta minus cos theta. Now sin theta minus cos theta, sin theta minus cos theta I am cutting. So this became sin square plus cos square will be 1 plus sin theta cos theta whole upon sin theta cos theta. So this I can write as sin theta cos theta upon sin theta cos theta plus 1 upon sin theta into 1 upon cos theta. So this whole got cancelled, so it is 1 plus 1 upon sin is cosec. Here I am given 1 plus sec a upon sec a equal to sin square a upon 1 minus cos square a. So first I am taking LHS and I am converting everything into sin cos. So this will be 1 plus 1 upon cos a whole upon 1 upon cos a. So in the numerator making LCM, I will get cos a plus 1 upon cos a whole upon 1 upon cos a. So now this will be cos a plus 1 upon cos a into cos A upon 1. So cos A got cancelled, so I got 1 plus cos A. Now, multiplying and dividing both numerator and denominator by 1 minus cos A, I will get 1 plus cos A into 1 minus cos A upon 1 minus cos A. So 1 plus A into 1 minus A will be 1 minus A square. So this became 1 minus cos square A upon 1 minus cos A. Now 1 minus cos square means sin square A. Next one is cos A minus sin A plus 1 upon cos A plus sin A minus 1 equal to cosec A plus cot A using identity cosec square A equal to. Now I have to use the identity cosec A square equal to 1 plus cot square. So now first again I am doing the same thing, LHS cos A minus sin A plus 1 upon cos A plus sin A minus 1. Now I am dividing the numerator by sin and denominator also by sin. So I will get cos A upon sin A minus sin A upon sin A plus 1 upon sin A whole upon cos A upon sin A plus sin A upon sin A minus 1 upon sin A. So cos upon sin means cot A minus sin upon sin means minus 1 plus 1 upon sin will be cosec upon again cot A plus 1 minus cosec A. So this will give me cot A plus cosec A. Now instead of 1 I am writing cosec square A minus cot square A upon this I am keeping as it is. So cot A minus cosec A plus 1. I have just rearranged the denominator. This I have done using the identity. So this I will get as cot A plus cosec A. If I keep this in one bracket minus, here also I can say cosec A minus cot A and cosec A plus cot A. A square minus B square formula I have used, whole upon cot A minus cosec A plus 1. So now cot A plus cosec A I am taking common. So I will have 1 minus cosec A plus cot A whole upon cot A minus cosec A plus 1. So this bracket get cancelled. So I got now next one is root of 1 plus sin A upon 1 minus sin A equal to sec A plus tan A. So here LHS I am taking 1 plus sin A upon 1 minus sin A. And I am rationalizing it. So I am multiplying with 1 plus sin A upon 1 plus sin A. So this will be root of 1 plus sin A whole square upon 1 minus sin square A. Now 1 minus sin square A means cos square A. So I can show it like this. See, 1 plus sin A whole square upon cos square A. Now whole square is there, so I can take it out of root, so that will be 1 plus sin A upon cos square will become as cos A. So this becomes 1 upon cos A plus sin A upon cos A. So 1 upon cos A means sec A. Sin up. Next one is sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta equal to tan theta. So again I am taking LHS and I will prove it equal to RHS. From the LHS I am taking from the numerator sin theta common. So I will get 1 minus 2 sin square theta upon, from the denominator I am taking cos theta common. So 2 cos square theta minus 1 I got. Now 1 I am writing as sin square plus cos square. So sin theta into sin square theta plus cos square theta minus 2 sin square theta whole upon cos theta 2 cos square theta minus sin square theta minus cos square theta. So I have multiplied the minus with sin square and cos square. So now you can see sin square theta and minus 2 sin square theta. So this will form sin theta into cos square theta minus sin square theta whole upon cos theta into 2 cos square minus 1 cos square will be 1. So I will get cos square theta minus sin square theta. Now cos square theta upon minus sin square theta will get cancelled. So that is sin theta. Now next one I am given sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. So here also first I will take LHS. I will follow the whole square bracket. So I will get A plus B whole square. So A square, that is sin square A plus 2 sin A cosec A plus cosec square A plus cos square A plus 2 cos A sec A plus sec square A. Now we know that sin A and cosec A are opposite of each other. So this 2 will get cancelled. Same way cos and sec will get cancelled. So 2 plus 2 I got 4 plus sin square A plus cos square A plus 1. Now I am left with cosec square A plus sec square A. Do like this. 4 plus 1 is 5. Now plus cosec square I can write as 1 plus cot square, and same way sec square I can write as 1 plus tan square. So this makes it 5 plus 1 6 and plus 1 7 plus cot square A cosec A minus sin A into sec A minus cos A equal to 1 upon tan A plus cot A. So first I will take LHS and I will prove it into RHS. So see, cosec A I am writing as cosec A minus sin A I am writing 1 upon cosec A. Same way sec A as it is and minus 1 upon sec A. Now doing the LCM I will get cosec square A minus 1 upon cosec A into sec square A minus 1 upon sec A. So cosec square A minus 1 will be cot square A upon cosec A into sec square A minus cot square A I am converting to tan and cosec A I am converting to sine. So cosec A means 1 upon sine A. So sine A will come up and cot is opposite of tan. So that will be tan square A in denominator into tan square A I am keeping as it is and sec A will be 1 upon cos A. So cos A will come here. So tan square got cancelled. So I got sin A cos A. Now this I can't solve ahead. So as told, I have to solve both the left hand side and right hand side. So now I am solving right hand side. 1 upon tan A plus cot A. So 1 upon tan A I am writing as sine upon cos plus cos upon sine is cot. So making it LCM there, sine square A plus cos square A upon sin A cos A. Now denominator will be numerator, sin A cos A upon sine square plus cos square is 1. So I got sin A cos A. Now next one is 1 plus tan square A upon 1 plus cot square A equal to 1 minus tan A upon 1 minus cot A whole square equal to tan square A. So now first I am taking the 1 plus tan square A upon 1 plus cot square A and I will prove it into tan square A. So this, can I say 1 plus tan square A will be sec square A upon 1 plus cot square will be cosec square. So still giving the form of sine and cos, I will have 1 upon cos square A upon 1 upon sine square A. So this comes to sine square A upon cos square A, which is equal to tan square A, which is nothing but my RHS side, that is tan square A I want. Now the second part, it says I want 1 minus tan A upon 1 minus cot A whole square to be tan square A. So here I can't do anything else leaving converting it into sine cos. So I am converting it into sine cos. So 1 minus sine A upon cos A whole upon 1 minus cos A upon sine A and whole square. So now doing the LCM, I will get cos A minus sine A whole upon cos A whole upon sine A minus cos A upon sine A whole square. So this comes to cos A minus sine A whole square upon cos square A into sine square A upon sin A minus cos A whole square. So I can cut this too. So it will be sine square A upon cos